Hi viewers, I'm preparing polypyrrole conducting polymer, and in the top bath you can see a plaque of wood which is undergoing polymerization on the surfaces, and the next one would be a piece of so-called acrylic paper where artists can paint with acrylics on paper the way that watercolorists would. And the bottom is where the pyrrole was the pyrrole bath for first coating these surfaces for 5 minutes at room temperature. Then the pieces were dripped reasonably dry and placed in a bath of iron 3 chloride, 8 grams and 100 milliliters of 0.3 hydrochloric acid. And these can be placed in the refrigerator for a few hours, but I'm doing these at room temperature because I'm very interested in when they're rinsed and dried, the resistance values. Over here, I'm using dressing that would be used with a wound. Let me see if I can pick this up a little bit. I'm very interested in this. And what I'm using after the dipping in the pyrrole bath, I then drip dry, as in the first case, and then I add ammonium persulfate, aqueous ammonium persulfate. And I want to see how this will work. After removing these treated surfaces, which I would use as electrodes in certain cells of interest to me and in supercap design, you can see that this is a polypyrrole which has been isolated that did not adhere to the surface. So that can be used in other applications, for example, with some polyacetate or epoxy binder, but I was able to, I want to cut down on that. I want to use just enough that I can coat the surface of these materials and minimize waste. I like the ammonium persulfate, and I think if I use a smaller concentration, I have about a 1 molar solution. If I can cut that down, even if it goes 24 hours, I may get smaller particle adherence to the surface. I like this gauze. That's very interesting, and presumably it's cotton. I'll have to do some homework on it. I'm also going to use some cotton and treat it in this fashion. I'll keep you posted on my results. Thanks for watching. Bye for now.